Well, hey there, kiddos, and here is your video on direct variation, which is going to seem very familiar to you because it's a lot like when you were in 8th grade and you were talking about whether or not something was proportional or not. It's the same kind of a concept, except now we're going to have an equation associated with it. So direct variation has an equation, and it looks like this. It's y is equal to kx, and if you're thinking that looks familiar, it's because it's very similar to y equals mx plus b, except when we're doing direct variation, there's no plus b because the y-intercept is going to be 0, because to be direct variation, the graph has to cross through the origin. Otherwise, it's not direct variation. The k in this is very similar to m. When we're doing y equals mx plus b, m is the slope. In this, k is considered the constant of variation. But it's the same thing as slope. If I find the rise over the run, or I find the change y over change in x, it's the same thing in this situation. The big difference is that for direct variation, it is always going to be plus 0. So there will never be anything added or subtracted to it. It's just going to be k times x. So I want you to pause for just a second, and I want you to go read this paragraph about George Ohm and the results of his work with electrical current and Jackson's experiment he's going to try. And then as soon as you're done reading it, come back and we'll finish with the problem. Alright, so hopefully you took a second to read, and you are told up here in this paragraph, just like we're told at the beginning of number 1, that voltage varies directly with current. And if that happens, if voltage varies directly with current, what function can Jackson, the guy making the experiment, use to represent the relationship between voltage, which is f of x, and the current in the circuit, which is x? We'll go back to the equation for direct variation, and the equation he can use is going to be f of x is equal to k times x. We just don't happen to know what k is yet. So we're going to go find it so we can write an equation and then use it. So we're going to create a table based on what we know given to us up here in the problem. And then we're going to use that information to help us write an equation and then use that equation to fill in the rest of the table. So we know up here that he had a power supply of 120 volts that measured 4 amps. And so right here in my table, 4 amps was 120 volts. I also know, because I was told, you were told twice in the paragraph and then in question number 1, that it is a direct variation. It varies directly. That right here, when x is 0, y also has to be 0 because it must go through the origin. This point has to be 0, 0, or it's not directly varies. It has to be. So now I have this. I'm going to use this so I can find k, which is the same thing as finding slope. So I'm going to find the change in my y values and the change in my x values. So k is going to be, the change in my y values is 120. The change in my x values is 4. And so the change in y over change in x is 120 over 4, which is equal to 30. So I'm going to use that to rewrite Jackson's function right here as f of x is equal to 30x. Now this equation I can use to finish filling in my table. I can just plug in my amps or my x values into here, multiply by 30, and I'll get my volts. So if my amps is 2, 30 times 2 gives me 60. If my amps is 6, 30 times 6 is 180. And then if my amps are 8, that's 240. And if the amps are 10, it's 300. And so there's my table that goes with this, and I got all of those missing values by using this function, just by knowing that the slope or the constant of variation was 30. Alright, so numbers 4 through 6 just want us to determine whether or not it's an example of direct variation, and if it is, to find out what k is. So remember, the equation is y is equal to kx. So it has to be a number times x with nothing added or subtracted. So look at number 4. I have y is equal to 4x. Well, that looks very similar to my problem here. There's nothing added or subtracted. So yes, this will be direct variation. And k is equal to 4 because that's my number in front of the x. Now for number 5, I can't decide yet because y isn't by itself. It has to say y equals. So I'm going to subtract 2x from both sides of this equation. And when I do, I'm going to get y is equal to, and I'm going to put the x term first, negative 2x plus 10. Well, if you'll notice, this one has a plus 10. It's got a number added to the end down here, so it does not match my direct variation. So no, this one isn't. So number 6, again, I need to get y by itself. So the first thing I'm going to do is add 3x to both sides. And I get 5y is equal to 3x. And then I'm going to divide both sides by 5. And when I do, I get y is equal to 3/5 x. Again, I have a number times x with nothing added or subtracted. So yes, this is an example of direct variation. And k in this problem is 3/5. So that's how we tell. If the equation is just a number times x with nothing added or subtracted, then you've got a direct variation. So number 7 here, the value of y varies directly with x. You love it when they tell you that because then you know what the equation is. We want to write a function that represents the relationship between x and y if y is 16/5 when x is 10. So the first thing I need to do is find k. So I'm going to start here with y is equal to k times x. I don't know k, but according to my problem, I know y and x. So I'm going to plug them in. Y is 16/5. And then x is 10, and so I'm going to write this as 10k because it's traditional notation to put the number before the variable. If you put k 10, it's the same thing. Now I'm going to solve this for k. First of all, let's make our fraction disappear. So we're going to multiply by that denominator 5. So I end up with 16 is equal to 50k. And then I will have to divide both sides by 50. And so you get that k is equal to 16 over 50, which if you simplify is 8 over 25. And so for part B, to write the direct variation equation, it is y is equal to 8 over 25x. So number 8, they've changed the variables on us, but not the way the problem works. So it says the amount of chlorine C needed for a swimming pool varies directly with the amount of water W needed to fill the pool. Well, we got to do independent, dependent real quick so we know what's X and what's Y. So the amount of chlorine depends on how much water is in the pool. So Y, the chlorine is dependent, it's the Y. The water is independent, it's the X. So if 16 units of chlorine are needed for every 1,250 gallons of water, write an equation that represents this situation. Well, it's direct variation because it says so right here. So it's going to be y is equal to kx, and I'm going to replace my y and my x with the variables they gave me in the problem. So chlorine is y, and water is x. So all I did was swap them out. And then I'm going to replace my c and my w with what I know. I have 16 units of chlorine for every 1,250 units of water. And so I need to find k. That's step number 1. So I'm going to divide by 1,250. And when I do, I get that k is equal to 0.0128. But I'm not done because it says write an equation. So I have to say c equals 0.0128 w. And I'm using those two variables because that's what they gave me in the problem, and so I need to use the notation they're giving me. So number 9, if y is directly proportional to x and y is 8 when x is 10, what's the value of y when x is 5? Well, first of all, now they've changed the word from varies directly to directly proportional. It means the same thing. Here's the other thing. In the first problem up here in number 7, they only gave me 2 numbers. They said y was 16/5, x was 10. But down here in number 9, I'm given 3 numbers. Y is 8, x is 10, x is 5. This word proportional tells me I can set up a proportion. X over y is equal to x over y, and I'm going to plug in the values that I know. I know that y is 8 when x is 10. I want to know what y equals when x is 5. So now I have a proportion I can solve by cross multiplying. So 10 times y makes 10y. 8 times 5 is 40. So that gives me an equation that I can solve. And when I do, I divide both sides by 10, I get that y is equal to 4. So there is my answer to that problem. I now know what y equals. So number 10, If y varies directly with x, use the table below to write a function that represents the relationship. All I have to write a function is k, which is slope. So I have to do change in y over change in x. So I have to do my change in my y values over my change in my x values. Well, if I do my change in my y values from 216 to 270, that's a change of 54. And my change in my x values is 3. So k is going to be 54 over 3. And if I do that math really quick, I get that k is equal to 18. Well, now to write a function, I'm going to have f of x, or y equals 18x. That's the function. And if you wanted to test it to see if it worked, you could plug your x values in. If you do 18 times 12, I bet you it's 216. If you do 18 times 15, I'm pretty sure it is 270. And if you do 18 times 17, it's going to equal 306. So you can check it really quick with your calculator. So last question here. A student says that y varies directly with x because as x increases by 1, y also increases by 1. Using the student's table below, determine whether the student is correct. Well, one of the definitions we didn't really go over is that to vary directly, as one variable increases, the other variable also increases. Or vice versa, if one variable decreases, then the other one also decreases. So your x and your y values are always doing the same thing. They're either always increasing or always decreasing. And so that's where that argument right here, as x increases by 1, y also increases by 1, comes in. But you also have to remember that in direct variation, the graph or the function has to pass through the origin. It has to have the point 0, 0. And if you look right here, it doesn't have the point 0, 0. It has the point 0, 3, which means the y-intercept for this graph is at 3, which means that when you write the equation, it is something x plus 3. It's got that number added. The only way this is a direct variation is if this number right here is a 0. 0, 0 has to be part of the function. So this is not correct. And the reason the student is incorrect is because it does not pass through 0, 0. The function does not contain the point 0, 0. Zero, 0 is a must. If it's not there, it is not a direct variation. So we'll practice this when you guys come into class tomorrow. I hope you have a good rest of your day, and I will see you then.